We're going to look at examples of continuity and discontinuity and examine the differences between the two. Continuity is a fairly simple concept. When looking at the graph, if there are no breaks or holes within the certain interval, it is continuous for that interval. We need to know about continuity because only continuous functions can be differentiated. Here are some examples. The graph of f here is a continuous function. Anytime the graph can be drawn without lifting your pencil, the function is continuous. The mathematical justification for this is, at any point in question, we check if at that x value there is a y value that corresponds, called c. Next, we check if the limit as x approaches c exists. Finally, if the limit as x approaches c equals the value at c, the function is continuous. On the graph just shown, all of these conditions are satisfied. Therefore, f is continuous on interval from -4 to 4. Now that we have seen continuity, let's look at discontinuity. When any of these three tests mentioned before is not true for the function is discontinuous. Here are some examples of discontinuity. This graph does not satisfy the first test. F of -1 does not exist, therefore the graph is discontinuous. This graph also does not satisfy the first test. F of 2 does not exist, therefore the graph is discontinuous. In this graph, f of -1 does exist, but when checking the second test of continuity, there is a problem. The limit as x approaches -1 does not exist, therefore the function is not continuous. In this final example, f of -1 exists. So does the limit as x approaches -1. But the final test of continuity says that the limit and actual value must equal each other. This function is discontinuous because it does not satisfy this third test. The end.